Given a logarithm of the form y equals log base b of x, the domain of the log is x is greater than 0. This just means that the argument x within the log can only be positive real numbers. Positive only, no negatives, not even a 0. To find the domain of a log, you need to set the argument itself, what's inside the parentheses, of the log greater than 0, and then solve. So we're going to find the domain of each log, and we're starting to start off with f of x equals log of x minus 3. So x minus 3 is the argument. It's what's inside the parentheses. So I'm going to take x minus 3 and set it greater than 0. All I do is add 3 over, and x has to be greater than 3. So the domain of this logarithmic function is going to be 3 to infinity. Now, along with this, you can also get what's called a vertical asymptote from it. And what that is just this inequality just written as an equality. So x equals 3 is also a vertical asymptote. Next, we have g of x equals ln of x plus 1. Again, what's inside the parentheses is all we're focused on. So we're going to take x plus 1, set it greater than 0, and solve. Subtract 1 over. X is greater than negative 1. So that means my domain is going to be negative 1 to infinity. And again, there is a vertical asymptote for this function at x equals negative 1, just coming from this inequality. Here we have a big one. H of x equals 2 log base 3 of negative 2x minus 5 plus 1. That's all well and good. Whole bunch of stuff going on, but I don't care about most of it. I just want what's inside the parentheses. So I'm going to take what's inside there, negative 2x minus 5, and set it greater than 0. So I'm going to add 5 over. Negative 2x is greater than 5. And then I'm going to divide negative 2 over. X is going to be less than negative 5 halves. Just remember, when you divide or multiply by a negative, the inequality sign has to flip. So this is my domain, and I'm going to write it out as negative infinity to negative 5 halves. So there's my domain, and just to write it in there, the vertical asymptote is again just going to be x equals negative 5 halves, just our inequality set as an equal to. Last, we have ln of 1 over x plus 1 minus 32. Again, all I'm doing is I'm going to focus on the parentheses, just the argument. So 1 over x plus 1 is greater than 0. So here I actually have a rational inequality. So what you have to do here is you have to set the numerator equal to 0, which is not possible, it's just a 1. And you have to set the denominator equal to 0. So we're going to get x plus 1 equals 0. And when we subtract 1 over, x is going to equal negative 1. Which is nice, but because it's a rational inequality, we need to see what's true and what's not. So put negative 1 in here, and we're going to do some test points. So negative 2 and 0. And I'll plug each one individually into my inequality here and see what's true and what's false. So negative 2 first, going to have 1 over negative 2 plus 1 greater than 0, which is going to give me 1 over negative 1. Well, that's going to be a negative divided by, or a positive divided by a negative, which is going to be negative. So this is going to end up being false, so it's not true here. Now I'm going to put 0 in, And we get 1 over 0 plus 1 is greater than 0, which is just going to be 1 over 1. So again, a positive is greater than 0. That is true. So this side is what's true. So the domain is going to be -1 to infinity. And we should have a vertical asymptote, again, at x equals -1, because this is where it cannot cross.